So this is a Unit 3 test, and let's just go through it. First of all, we have to, on these problems, we want to look at the degrees of the numerator and denominator. Now the degree of this numerator is 3, because the term with the highest power of x is this one, and it's degree 3. And the denominator, see, if I multiplied this times this, I'm going to get an x squared, and take it times an x. I'm going to get x to the third, so it's degree 3. Well, if they're equal degrees, we want to look at the leading coefficients. The leading coefficient here, that's the number that tells us how many of that term we have. Well, we have minus 2x to the thirds, and down here we're going to get 1x times 1x times 1x, which is going to be 1x to the third, and up here we got a minus 2x to the third. So we look at the leading coefficients, and that's minus 2. So this, in the long term, will approach a line of y equals minus 2. Minus 2 divided by 1, minus 2. Looking at the degree here, let's see, we have x to the third in this one. Its leading coefficient is 2, but it's x to the third. This one is x squared. So the degree of the numerator is more than the denominator, and when that happens, we need to do some division. Now, I'm going to go x squared minus 1 divided into 2x to the third minus 5x squared plus 3, and I have to decide what times x squared makes 2x to the third. It'd have to be multiplied by a 2 and another x. So 2x times x squared is 2x to the third, and 2x times a negative 1 is minus 2x. And in division, we normally subtract at this point, so that's why I say draw the line and change the sign so we can add all the like terms here. X cubed, these are like terms. They add to be 0. We have an x squared, an x, and a 3, so those are all unlike terms. They all are separate. So I got minus 5x squared plus 2x plus 3. X squared times negative 5 will make negative 5x squared. And negative 5 times 1 is negative 1 is plus 5. But I really don't need to go on any further because I've got what it's going to be. This graph, since the numerator is bigger than the denominator, is going to have an oblique or slant asymptote. It's going to approach a slanty line. That line that it approaches is 2x minus 5. Now, some of you on the test tried using synthetic division. Well, whenever this is squared, that's a problem, or if there's a coefficient in front of it, because you're supposed to use what equals 0. What would make this equal 0 in synthetic division? And you can do this one because this factors to x plus 1 and x minus 1. And since it does, we can use minus 1 into this and then go back and do plus 1 into it. So we're going to have to divide twice to get this one. So I'll do that for you. Excuse me. Early morning. So minus 1 will go, makes this factor equal to 0, so I'm going to use minus 1 into, oh my goodness. Okay, hopefully I'm done with that now. So we have 2x to the thirds minus 5x squareds, no x's, and a 3. So I'm using the minus 1. 2 plus nothing is 2, times minus 1 is minus 2. This would be negative 7 adding, times the minus 1 is plus 7. And this would be 7 adding, times minus 1 is minus 7. and we get -4. We don't really care about the remainders. Now we have to go again with, this is x minus 1, so I got to use plus 1. And I'll go into this, and I'm going to get 2 plus nothing is 2, times 1 is 2, add, and I get -5. Multiply by 1, I get -5, and I get 2. That's my remainder, but I don't care. This is telling me what it was. I was going into x to the third, became x to the second, became x to the first. Y equals 2x minus 5. Okay, so if this can be factored with only 1s in front of the x's, you can get to the equation of the oblique asymptote that way. That's if the numerator's degree is greater than the denominator. The degrees were equal. The degree of the numerator was greater than the denominator. In this case, the degree of the denominator, 3, is greater than the numerator's degree, 2. When that happens, whenever the denominator has a higher degree, it's going to get larger than the numerator as x gets large. And so this is going to approach a fraction where we have a really large denominator over a numerator, but under a numerator is going to go to 0. So this is y equals 0. Once again, degrees are the same. Ratio of the leading coefficients, the numbers in front of the highest exponents. If the degree of the numerator is greater than the denominator, do long division. If the degree of the denominator is greater than the numerator, then it's just 0. And they're equations of lines, and so you need to write equations. Okay, on this one, we really want to look at the information in the graph. There is a vertical asymptote at 1. There's a vertical asymptote at either 5 or 6, hard to tell on the graph. I'm going to say 5 because this looks like it's going pretty straight down to avoid this. This one looks like it's drifting over, and it won't be at 6. Looks like it's going to head over towards 5. So that's my guess on that. No other asymptotes vertically, but there is a horizontal asymptote, and this is what many of you forgot to look at. So now, the vertical and the intercept. So we have x equal 1, x equal 5, y equal -3, and we have an intercept that looks like at 3.5, and it's a bounce, so it's a double one. And this one goes straight through at 0. So the numerator is controlled by the x-intercepts. So x must be a factor, or x minus 0, in the numerator, and x minus 3.5. And that one's a bounce, so it's got to be squared. So we got at least a degree 3 in the numerator, and to have a horizontal asymptote that's not 0, the degree of the numerator and the denominator have to be equal. So we have to have 3 factors in the denominator, a degree 3 in the denominator, and we have at x equal 1 a vertical asymptote, which means x minus 1, and the curve went in opposite directions at that asymptote, which tells us the degree of it is 1, or the multiplicity is 1. And then we have another one at x equal 5, so that means x minus 5 must be in the denominator, and we notice that this goes in the same direction by that one, which tells us this has a multiplicity of 2. Now I have a degree in the numerator. That's 3 x times x times x, because there's two of them here, and degree 3 here. And this looks pretty good for my function, except that if I left it like this, the leading coefficient would be 1 on here, 1x to the third if this was expanded, and this would be 1x to the third, and my leading coefficient would be 1. But the ratio would be 1, and my horizontal asymptote would be y equals 1. It's supposed to be -3, so I need to put in a negative. If I put this in like it is right now, I'd get this flipped over and also getting close to 1, not to 3 in the distance. So I need the -3 here to flip it over and to bring that horizontal asymptote down to 3. So that's what a lot of people missed. Okay. This one. Now I gave points for factoring this because it's pretty hard to do anything with this if you don't factor it first. So we're going to do this, and when we factor it, we've got to watch out for a constant. Many of you missed that. So I'm going to type in the numerator into my calculator here. It's the easiest to show on here. So 4x to the third minus 8x squared plus 4x to the fourth. Okay? And so if I graph that, I see that it goes through -2, which means x plus 2 is a factor. It bounces at 0, so x squared is a factor. And it goes through +1, which means x minus 1 is a factor. But again, this would make a leading coefficient of 1x to the fourth. And we had 4x to the fourth, so there must be a 4 times it. Now you can check this, make sure you've got everything by typing in what we had, what we saw as the factors, parenthesis x plus 2, close parenthesis, times x squared, and then parenthesis x minus 1. If we graph that, you'll see it doesn't quite match. But if we go back and put a 4 in front of it, or behind it somewhere, multiply it by 4, there's the first one, and now this one matches perfectly on it. So we've got it factored correctly. Now let's factor the denominator. So we come up here and we've got x to the fourth plus x to the third minus 7x squared minus 13x minus 6. So I'm going to graph. And this one goes through -2, so that means x plus 2 is a factor, and it goes straight through. It bounces at -1, so x plus 1 is a factor twice. And it goes through +3, which means x minus 3 is a factor. Leading coefficient on this would be x times x times x times x, x to the fourth, one of them. And that's what we have, so we don't have a constant there. So there's the factored form that I gave points for. Now to determine a whole, if we got a factor in the denominator that's also in the numerator, that's usually a whole, and that would happen at -2. And to find the whole, I have to put -2 into the one graph that looks like this graph would, except for without the whole. So I'm going to cancel those out, and there's no x plus 2 left, so this is going to be a whole. And I have 4 times x squared times x minus 1 over x plus 1 squared times x minus 3. This is going to look the same except without the whole. Now if I put minus 2 in here, I get 4 times minus 2 squared is 4. And minus 2 minus 1 is minus 3 over minus 2 plus 1 is minus 1 squared is 1. And minus 2 minus 3 is minus 5. So I've got 16 times 3, which is 48, and it's negative. And I have 1 times negative 5, which is negative 5. So the negatives cancel, and I get 48 fifths, or 9 3/5. So that's the y-coordinate of the whole. Okay. Vertical asymptotes and the behavior. So since this was a whole, it's not a vertical, not contributing to the vertical asymptotes. But we have one here at minus 1. So we write the equation of the vertical asymptote, x equals negative 1. And since it's a squared, the graph is going to go in the same direction, either up or down, whichever way. It goes in the same direction as it approaches it. As it approaches that line, it'll go either both up or both down. And the other one is at minus 3, or x minus 3 causes it, so it'll be at x equal plus 3. And since its multiplicity is 1, or odd, it's going to go in opposite directions at it. So they either go the same direction or opposite for the behavior at the asymptotes. Determine the horizontal or oblique asymptote. This again depends on degree, just like in problem 1. This is degree 4, this is degree 4. If they're the same degree, it's going to be y equal the ratio of the leading coefficients. Leading coefficient here is 4 on the x to the 4th, and it's 1, so it's 4 over 1, or 4. Now you need to determine the x-intercepts. Well, that's what makes the numerator be 0. And again, we've found that was a whole, so that's not it. So it's going to be 0. We'll make the whole equation 0. And it happens twice, so it bounces there. And 1 would make it 0. If I put 1 in here, the numerator is 0, and we have 0. So, and that's a degree multiplicity of 1, so it goes straight through. So we're building the picture of what this graph is going to look like. Now, of course, you can graph it on a calculator, but I'm looking for these details in the graph. What happens when f gets very large? Well, as x gets very large, we're headed out that way, and it heads towards the y equals 4. It approaches the graph, approaches y equals 4. A height of 4. You can say the height of 4 or whatever you want. What are the y-intercepts? That's whenever x is 0. So if we put 0 in for x, We get a numerator that's 0 because of that, and the denominator would not be 0, so we get 0 out. Local maximum and minimums. So, well, now we're going to have to look at the graph. And so we're going to graph this thing, and I'm going to start working on the graph here by putting some of the stuff we know. There's a hole at -2 and 9 3/5. So I should be showing 9 3/5 -2 a hole. Okay? And I should be showing a vertical asymptote at -1 and a vertical asymptote at 3. So I would expect you to draw something on your graph to show those. And a horizontal asymptote at 4. So I should see a hole, and I should see these lines. And at 0, 0, it bounces, and it goes straight through at 1. Okay? So I should see these points on your graph. And y-intercept is 0. So now, what does it look like? Well, if there's a hole up here, it's probably going to approach this asymptote on this side, and in the long run it gets close to 4, so it probably goes like this. This is without even looking at the graph. And at -1, they went the same direction on either side, so it must come from above and come down and bounce at 0, it said. So it has to come down and bounce at 0, then go up, and then go straight through at 1. So comes straight through, and so it must be going down, so it must head down towards this line. And if that's the case, at 3 it went opposite, so it must come from above and drop down and go something like this. So in the graph, I'm looking for in the intercepts, the asymptotes, and the hole. And the graph in the right place using the whether it goes in the same direction or opposite direction at the asymptote. So I'm looking all for those details in it. So now I can see that there's going to be a maximum between 0 and 1. Not very big. It's only going to be probably less than 1. It could be more than 1, but I think probably less than 1. So now let's go and actually graph. And some of you graph the reduced form, so you wouldn't see some of the stuff. I recommend that you graph the original equation so that you're not making a mistake. So that's the denominator. I don't think I can, well, let's see. Second insert, I can put a parenthesis there. And I can put a parenthesis there, so now I can insert the numerator in front of this. Second insert, and I want to go parenthesis 4x to the third minus 8x squared plus 4x to the fourth, down and close parenthesis, divided by, and then insert a parenthesis, and I should have an x right there. Does this look right now? 4x to the third minus 8x squared plus 4x to the fourth divided by x to the fourth plus x to the third minus 7x squared minus 13x minus 6. I think so. So we push graph. So I must be in too close because I'm not seeing these two parts, but it's a good view to see this, and so I'm going to find the local maximum there by going second, calculate the maximum that's between 0 and 1, and it's about 0.5. It happens at 0.6. That's not what I'm concerned about. I want the maximum, which is 0.09375. 0.09375. And I can see also that there's a minimum right there. Right there. And we know that's at 0, so we know the height of that place is 0 because it goes through 0, 0. I can do the calculations on the calculator, but I don't need to. I've now sketched the graph, and I've checked my graph. Oh, I better check and make sure that these are there. So I'm going to go zoom 6, goes up, comes down, and then comes down over there. So that graph looks correct. And there's a hole up here near 9. Second, calculate the value of the graph, and we thought that hole happened at -2. And so I'm pushing in the value at -2, and it leaves this blank which says, yes, there is a hole in the graph. Okay? And when is this graph less than or equal to 0? For what x's, and this is how you read this, for what x's is the y less than equal 0? Well, for these x's, the y is above 4 and higher. For these x's, it's equal to 0 at 0, and it's less than 0 from 1 to 3. So it equals 0 at 0, so on the interval from 0 to 0, or in some books you'll just say put 0 in the interval notation. Union, the other place where the graph is less than 0, the y values are less than 0, are from 1 to 3, and at 1 it is equal to 0, and at 3 it can't because that's an asymptote, so it's a parenthesis. Okay? And that's that page. So now the last page. Let's go through this one. We're taking groups of 3. Now 40 is 8 times 5, so that's 2 to the third times 5 times x times y to the third, and we're doing the 1/3 power. We're taking out groups of 3. So the 2 will come out, the 5 will not, the x will not, and the y will come out, and we don't need absolute value because it's an odd root. Okay, we're doing square roots. So we're taking them out in pairs, so this is the 1/2 power. We have a 5 already out. 81 is 9 times 9, which is 3 times 3 times 3 times 3, 3 to the fourth, x to the 5, minus, there's not much we can do here, so minus 2x squared, square root of x. We're taking out pairs, so there's a pair of 3's come out as a 3, and there's a pair of 3's that come out as a 3, so I got 3 times 3 times 5. 3 times 3 is 9, times 5 is 45, and we have 5 x's. A pair of them come out as an x, the second pair come out as an x, and there's still one left, so I got x squared. Don't need absolute value because squared is already positive. Square root of x minus 2x squared square root of x. These are like terms. Those look identical, so we have 45 of these minus 2 of these, so it's 43x squared square root of x. Next one. We're taking the square root, but we're doing of 3 of these. It's saying this is cubed and square root. Now some people did this with powers. So I'm going to do it with powers and then I'll do it the other way. So 12 is 4 times 3, or 2 squared times 3 times x squared times y to the third to the 3 halves. These are all multiplied so you can distribute the power, so you get 2 times 3 halves, which is 2 to the third, 3 to the 3 halves, x to the 2 times 3 halves is x to the 3, y to the third times 3 halves is y to the 9 halves, which means we have, this is straightforward 2 times 2 times 2, which is 8. This is 3 3's into square root, so a pair of them come out as a 3, and there's still a 3 under the square root. Or another way to look at this, 3 halves is 1 and 1/2, so we get a 1 3 out, and a 1 3 still in a square root. Same thing happens. The x to the third is there's no halves, so there's nothing left underneath. But this is an even root, and we're getting an odd number of them out, so we have to do absolute value. And on this is 9 halves is 4 and 1/2, so we get y to the fourth out. Don't need absolute value because it's the fourth, and we get a y still inside to the 1/2 power. So I get 8 times 3, 24. Absolute value of x to the third, y to the fourth, and still in the square root, still to the 1/2 power, we have a 3 there and a y. Now if I do it under square root, I have 3 of these. So 12 is 2 squared times 3 x squared y to the third times 3 of them, 2 squared 3x squared y to the third times 2 squared 3x squared y to the third, all under a square root. So I have 2, 4, 6 2's, and I'm taking them out in pairs, so there's a 2 from that one, a 2 from that pair, a 2 from that pair, which makes 8, like we had before. And we got a 1, 2, 3 3's. 2 of them come out as a 3, and 1 of them will stay under the square root. I have 2 x's. That pair will come out, that pair will come out, and that pair will come out. So each one of those would make an x, and so that's x to the third. Odd number of them, odd number cubed would be negative, and we don't want it to be negative because we're taking them out of square root. So we have to put absolute value on it. And we have y to the third, so that's 3, 6, 9 y's. 8 of them make 4 pairs, so y to the fourth, and there's a y left underneath. which is the same as that. You can multiply that, make it 24. All right, moving on. So looks like the common base here is 5. 125 is 5 to the third, but it's 1 over, so this is 5 to the negative 3, and this is 25, or 5 squared, to the 3x plus 2 equals, and this is already in 5, so it's to the x minus 3. So I have to multiply the powers here, so I got 5 to the negative 3 times 5 to the 6x plus 4 equals 5 to the x minus 3. And when you multiply with the same base, you add the exponents. Has to be the same base. So we've got 6x plus 4 minus 3, which is 6x plus 1 equals x to the 5 to the x minus 3. So now we got the same base, so the powers must equal, so I got 6x plus 1 equals x minus 3. Subtract x from both sides, subtract 1 from both sides, so I get 5x equals negative 4, divide by negative 4, and I get x equals negative 4/5, or negative 0.8, if you will. Common base here, 8 is 2 to the third, and that's to the x power. 4 is 2 squared, and this is 2 to the x plus 5. So when you multiply, you add the powers, so you get 2 to the x plus 5 plus 2, which is x plus 7. And here you multiply, so you get 2 to the 3x. So 3x has to equal x plus 7. Subtract x, and I get 2x equals 7. Divide by 2, and I get x equals 7 halves, or 3.5, or 3.5. Okay. The fourth root, well, that's an even root, so the inside cannot be negative. So 6 minus x has to be greater than or equal to 0. If I subtract 6 from both sides, I get negative x is greater than or equal to negative 6. Multiply both sides by negative 1, and I get x is less than or equal to 6. You have to flip the sign if you multiply by a negative. So x has got to be less than 6. Or you could type this into your calculator and graph and see that the graph only happens from negative infinity up to 6, including 6. In this case, cube root, the inside could be any number, so this is all reals. Or from negative infinity to infinity. On this one, after 3 days, this is predicting the population in thousands of insects, so we got to put in 3. So we got 3 times 3 times 3, which is 27, divided by 3 squared is 9. Half of 9 is 4.5 plus 2. So we got 27 over 6.5, which you can divide out, or you can leave it like this, and this would be thousands of insects. Okay? So what was the expected population after many days? So you can put a really big number in there, like hundreds or thousands, but what you should do, and from your knowledge on this, we have degrees that are equal, and so the population will, the limit as the t gets really large of this function, it's going to approach the horizontal asymptote, which is, since the degrees are the same, it's going to be 3 divided by 0.5. 0.5 is a half, and there half goes into 3 6 times, so 6,000 insects.